Hi, all. Today's lesson is on square root property. So the goal is that I can use square root property to solve quadratics. So remember quadratics, anything that has an x squared in it. So far we learned to graph, then we learned about factoring, and now we're learning about square root. So you can use this property when there is no b term, right? So when there's no b term, we can solve the equation by rewriting it as ax squared equals c. You'll remember that this is referring to the b term here in our standard form, ax squared plus bx plus c equals 0. If we don't have this portion here, right? If we do not have this portion, we are going to learn the strategy that we can use today. So there are two major steps. The first step is to separate the squared term, or the a term, right, from everything else. And then we're going to take the square root. And we want to never forget the plus or minus. Anytime you take the square root, you have both a positive answer and a negative answer. So let's go ahead and try our level 1 question. So step 1, separate the squared term from everything. So I see here's the squared term. There's an equal sign. Everything is separated away from it. So we did the first step. And then for my second step, I'm going to take the square root, making sure I remember positive and negative. So the opposite of a square is the square root. It is the inverse operation. So what I do on one side, have to do to the other. Square root and the square will cancel and leave me with just x equals. And I'm going to have the positive and negative version of the square root of 121. So I'm thinking of what two numbers multiply to get 121. They have to be the same in order to be a square root. So I know that that would be 11. If you don't know that, you can use your calculator. I like to use decimals. You can do the square root button is down here. So you can press square root 121, and you'll see that that's 11. The reason is because 11 times 11 is 121. So keep that handy over there. So if we're looking at this problem here, so anyways, this is how we get our two answers. Sorry about that. If you're looking at this problem here, we want to follow the same steps. So separate the squared term from everything. So here's the squared term. That means I want to get rid of the positive 36. I'm going to go ahead and subtract 36 on both sides. And I get y squared is equal to negative 36. That's my first step. My second step is to take the square root and not forget plus or minus. I'm going to go ahead and take the square root of both sides. It's going to cancel here and leave me with y equals the square root of negative 136. I'm going to go over here and find the square root of negative 36. And you'll see that it says undefined. This is because we tried to find the square root of a negative number. There's no one number that if we multiply times itself, we get negative 36. So we could try 6 times 6, but 6 times 6 is going to give me positive 36. If I do negative 6 times negative 6, it's going to give me positive 36 as well. If we just have one negative, that's true. It will help us get negative 36, but it has to be the same number to be the square root. So what we are going to write here is that there are no real solutions. There are two imaginary solutions. If you're someone who remembers the letter I, this is a situation where we'd have plus or minus 6i, because the square root of positive 36 is 6. And then I is how we represent the negative, the imaginary number set. For now, we're not going to do anything with that. We're just going to say no real solutions when we run into this problem. So a negative inside a square root equals this right here. Okay, awesome. All right, let's try some level 2 problems. We're going to follow the same 2 steps though. So we're going to, number 1, separate the squared term from everything. So here I see the x squared. That means that I need to get rid of the times 2 and the subtracting the 1. So I'm going to go ahead and add 1 to get started. It's going to leave me with 2x squared is equal to 24, 23 plus 1. All right, from there, I want to get rid of the times 2 that's in front here. So I'm going to go ahead and divide by 2. And I get x squared equals 24. I want to take the square root of both sides. That's my second step because I got the squared term by itself. I'm going to take the square root of both sides. It's going to leave me with x equals positive or negative. I'm going to write square root of 24 for now. There's no individual number. If I go back to my calculator here, there's no number that goes evenly into 24, right? So I have 16, 4 times 4, 25, 5 times 5. So I know that it's somewhere close to 5, right? And I know it's this decimal. So I could write equals positive or negative 4.89. Let's see, 898, but that next one's a 9, so it's going to round up to a 9. It could be this if I was looking for the decimal approximation. In some instances, you might be asked to recognize, I can do 24, break it down into 2 and 12, break that down into 2 and 6, break this down into 2 and 3. I see a group of 2s here. Those are going to go to the outside. And no more pairs are left, so these are left over. 2 times 3 back is 6. All right, so the square root of 24 is the same as 2 times the square root of 6. Let me go ahead and fix that here. 2 square root 6. Like that. So you can see they're the same decimal number. That's how I know that they are the same. So positive or negative, either one of these is a correct answer. If you're feeling more comfortable with the decimal, that's totally fine. If you like to break it down, you can also create the exact version. So this is the approximate, this is the exact. All right, let's try another one. So we have this one here. I want to get the square root or the squared term by itself. So I'm going to go ahead and subtract 4 on each side, leaving with negative 5y squared equals negative 16. You need to get y squared by itself, so dividing by negative 5, I get y squared equals positive 16 over 5. I'm going to go ahead and take the square root of both sides. It's going to leave me with y is equal to positive or negative square root of 16 over 5. If you want to, you could find the decimal approximation by going to your calculator. You can type in square root 16 over 5 like this, and you get 1.888. That 8 is going to turn this into a 9. So plus or minus 1.789. This is my decimal version. If you're interested in that in your, what is it called? Silly me. Your exact version, it would be square root of 16 over square root of 5. Square root of 16 I know is 4 over square root of 5. We have to do something called rationalizing, which is square root of 5 times the square root of 5. It's going to leave me with 4 square root 5 over 5. This is the same as that. You can see from your calculator. If you type in 4 square root 5, not 14, 4 over 5, you can see that these are the same decimals. So this is true for now. Our best possible answer is going to be our decimal version. This is just if you like the extra stuff. All right. Finally, we have our level 3. It's a little bit challenging. So we have we see that there's a difference here in that it's not just x squared, but it's actually this whole thing is being squared. So what I'm going to do is I'm going to go ahead and I know that this thing is being squared. So this part is squared. So I can't do plus 3 here because it is stuck inside of those parentheses. So what I'm going to do in order to get rid of the parentheses is I'm going to take the square root of both sides. That's going to cancel my square root and my square and leave me with 2x minus 3 is equal to the square root of 4, which I know is 2 times 2. So it's going to be positive or negative 2. So this square root of 4 is either positive 2 or it's negative 2. There are two solutions here. So I'm going to go ahead and say there's one version, 2x minus 3 could be equal to positive 2. And then there's 2x minus 3 could be equal to negative 2. Right, so two versions for this question because we have a positive or negative 2. I'm going to go ahead and add 3 on both sides. 2x equals 5 divided by 2. X equals 5 halves. Or add 3. 2x equals 1. X equals 1 half. Just like that. Right, so this is what we can do if we have parentheses and using our square, or it's squaring an entire, a number of terms together. Okay. All right. And then finally, we have this one here. I know that the 2 is only applying to the x in this case, not to the 100. So I want to get rid of the other things. Let me go ahead and add 25. I get 100 x squared equals 25. I'm going to divide by 100. I get x squared equals 25 over 100. Go ahead and take the square root of both sides. I get x equals square root of 25 over square root of 100, which conveniently is 5, because square root of 25 is 5 over 10, which is 1 half, or 0.5, whichever answer you like better. You could have also gone from this step, gone to your calculator, and typed in square root 25 over 100 and gotten 0.5 as well. So you can use either of these as your answer. Okay, thanks guys.